Florida's got one loss.
Say again?
Florida's got one loss.
Who did they lose to? Alabama. Yeah, that was the game so far. That was the game of the year. That was a good game. But Florida's a whole lot tougher than all the other teams. I think Florida's going to do something with the SEC. I think they're going. I think they could possibly beat Georgia, but Georgia hasn't been tested yet. So I think they'll be tested this weekend. All right, I got the recorder on, so I guess we got to talk about math. All right, so what was the last problem we did? Did we do the marbles? Is that what we did? And the golf balls or whatever?
Yes, sir.
All right, so let's go to 5.5. This test is going to consist of, let me go ahead and write it down so y'all won't ask these questions. This test is a Unit 2 test, and it will consist of 4.1, 4.2, 5.1, 5.2, 5.3, and 5.5. So if you've got your outline for the two people that actually printed it out, you need to mark off those other sections in Chapter 5 because I'm not going to cover them. In 4.1 and 4.2, I will test you on the, I can't think of the name of it, scatter plot. Scatter plot. Make sure you can do it on a calculator and the spreadsheet, or the spreadsheet and the spreadsheet, whichever. Correlation. Make sure you can test, excuse me, the correlation coefficient against a critical value like we talked about. Causality. Causality is more of a common sense thing. And slope and equation. Make sure you can calculate the slope and the equation given 2 points. Again, I'm not going to test you on residuals. Residuals, that work we did, residuals, that was for homework. So you could, finish your homework. 5.1, probability. Probability with a single event, like the probability of pulling a king out of a deck of cards, and sample space. What is the probability of having 3 girls with 3 children? 5.2 is the additive law. Always subtract the overlap. And always try to put in a table form. So go from a question to a table. The 5.3 is the multiplicative law, and this one is OR. This one is you got to do with or without replacement. And you've got to remember the word and. Okay? And say again. With replacement is independent. Without replacement is dependent. I think if there's no overlap is disjoint. No overlap is disjoint. And overlap, I guess, is jointed. I don't know. Joint. Okay. And 5.5 is on counting. And when I mean counting, I mean multiplication, exponents, factorial, and combination / permutations. There's the test right there. So we're going to go over 5.5 today. I didn't receive, I don't think I received any questions. Let me look right quick and see. So that means that y'all understand it. I got one, but that's from another class. So let's see, that's from another class. Yeah, I don't see any from this class. So that means y'all understand everything. Okay, so I don't have to go over any questions. That is good. Good thing about y'all. Y'all don't ask any questions, so y'all already know it. All right, so what is 5.5? Well, I'm going to pull up the handy dandy. Let me go down to 5.5 if I can find it. That's at least, I think that's 5.4. No, that's the multiplication rule. Okay, there's permutation right there. And I do permutation, I do combination first. There's factorial. Okay, must be meals. Let's see if they do the meals or the flags. Okay, they do the meal. All right, so here is an example of a test question. So I want you to write it down. You could have flags. You could have outfits or meals. And this is when you're given 2 possible options or 3 possible options for either a shirt, pants, shoes, or appetizer, entree, dessert. Everybody see the connection? Okay, it can either be shoes, shirt, pants, or it can be appetizer, entree, dessert. So you might want to put clothing / meal. And appetizer is super salad, so that's a choice of 2. And I'll just put this, that's aggravating. I can't do the whiteboard. Okay, I'll just wait until y'all finish. Or is this the whiteboard? Oh, that's a pen. I didn't know that was on here. Oops. What is this? I didn't know these were here. All right. So when you're doing this problem, you just write down the following things. There's 2 dishes. There's 1, 2, 3, 4, 5 dishes, right? 1, 2, no, 3, 4. 4 dishes. You know, I've been through the Marine Corps. I've been through Clemson University. And there's just several things that I've never developed a taste for. One is smoking. I've never developed a taste for that. The other one is coffee. And the other one is beef liver. I've tried it many different ways. I just can't eat it. Anybody out there love beef liver? Anybody? I'd eat it if I was starving, but I just never have developed that. And meatloaf. I don't like meatloaf either. And 2 dishes for dessert. Of course, y'all not going to say anything anyway, so I don't know. I'm just talking to myself, I guess. So that's going to be 2 times 4 times 2, which is equal to 16 different arrangements. So make sure you know how to do a problem like this. This is multiplicative. In other words, it's a combination of 2 dishes, 2 dishes, and 4 dishes. You got 16 different arrangements. Same thing with clothing. 2 pairs of shoes, 4 pairs of pants, and 3 shirts. I'm sorry, 2 shirts would be 16 different outfits. So I just wanted to give you 2 examples, so that way you know when to use this type of multiplicative counting. This is called multiplicative counting. Counting is when you basically do some form of combination, arrangement, or permutation. That's what counting is. Any questions on that example? That's pretty straightforward. All right, let's see what other example they got. There's the multiplicative. Multiplication rule of counting. You just multiply them together. Okay, here's one. This one is codes and license plates. Codes/license plates. And I always want to spell license with 2 C's. I don't know why I want to do that. So anyway, codes and license plates. So we're going to do 2 examples here. And the reason I'm going to do 2 examples is you might have both of them on the test. So codes and license plates. The things you got to remember, and I'm going to put this in red. So that means you might want to put it in red or highlight it. A through Z is 26. Now, if you don't know that, I don't know where you were in 1st or 2nd grade. Okay? 0 through 9 is equal to 10. And spaces, slots equals exponents. Okay, so let's read this question and see what it says. The International Transport Association, blah, 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 assigned 3-letter codes. So that would be 3 slot codes. 3 slot close. I can't speak. Codes. Now, why did I say 3 slot? Because there's 3 letters in the code, like LAX. LAX is Los Angeles Airport. Los Angeles International Airport. Now, Anderson don't have one because Anderson is not an international airport. I'm not going to say anything else on that. We think we are, but we're not. So 3 slot codes. It probably has a code. I don't know, but I don't think it's international. 3 slot codes. So I got 3 slots. And each slot is a letter. So that's going to be 26, 26, 26, 26. There's 3 spaces. So that's going to be 26 to the 3rd power. There's your space right there. If there was 5 spaces, if there was 5 letters, or five slot code, it would be 26 to the 5th. And I don't know what 26 to the 3rd is, so I'm going to pull up my handy dandy calculator. 26 raised to the 3rd power. And that's 17,576 codes. 17,576 codes. Okay. Next, let me go ahead and hold on just a second. I have to answer this. I'm sorry, that was the IT director. And when the IT director calls, that's like the doctor calling. You don't get a call back, so you have to answer it. So I'm sorry. Okay, let's do a license plate. License plate, and I hope I spell that right, but I always want to spell it with 2 C's. License plate. The license plate question is going to say, there's a license plate company that makes the license plate, or the prisoners make the license plate. You know, prisoners used to make license plate, but now prisoners have rights, so they don't make license plates anymore. Anyway, 3 letters on the left side of the license plate and 3 numbers on the right. So you got a license plate, looks like this. You got 3 letters here and 3 numbers there. How many different license plates can be made? There I go again. License, S. Plates can be made. And that's going to be 26 to the 3rd power times 10 to the 3rd power. Because you got 3 spaces here, and you got 3 spaces here, so you got to the 3rd power there, and to the 3rd power there. So we take our handy dandy calculator, and we already got 26, so we're going to multiply that by 10 to the 3rd power, and that is 17,576,000 different license plates. So hopefully you understand that. And that's everybody thumbs up on that one. Thank you. Who's taken probability and statistics before in high school? Anybody? Y'all haven't taken probability and statistics before? Okay.
We all took pre-cal last year.
Well, stick with the pre-cal. Try to take as much pre-cal and calculus as you can. I'm sorry, I shouldn't have said that. Shut up, Hubert. That way you get a good degree. Shut up, Hubert. All right. Next, let's go with another problem. Let's go with, got to do the arrangement of letters, and I don't want to do combinations yet. There's a flag question that you're going to get. We'll come back. There's factorial. Yeah, we need to do factorial. So let's go ahead and talk about factorial. Factorial. Anybody know what factorial means? Anybody want to take a stab at it? The symbol for factorial is the exclamation mark. And it means multiplying numbers in their natural sequence down to 1. So what is 2 factorial? 2 times 1. 3 factorial. 3 times 2 times 1. 4 factorial. 4 times 3 times 2 times 1. Or 4 times 6 is 24. 5 factorial.
Priority 1 message coming in on secured channel.
5 times 4 times 3 times 2 times 1. Or 5 times 24, which is what? 120? And 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1, which is 720, and so on. Now we got to put some red numbers in here. Got to put some red notes. 0 factorial is equal to 1, and 1 factorial is equal to 1. So you need to write that down also. And let's go to your handy dandy calculator, because your handy dandy calculator.
Priority 1 message
Good
coming in on
gosh.
secured channel.
Your handy dandy calculator is how you want to do these. So let's clear this and clear everything else and get out your calculator if you got it. Does anybody know where the factorial hangs out? Okay, so it's under the math key. Hit math, go over to probability, and the 3 keys that you need to know about are number 2, number 3, and number 4. Number 4 is factorial. So I'm going to do 7 factorial. Clear, clear, type in a 7, go to math, go to probability, and go down to factorial. Now, of course, you can hit 4 if you want to, and enter. And 7 factorial is 5040. So 7, math, probability, number 4, factorial, and enter. And that should give you 5040. Now, when do you use factorial? Well, for the rest of chapter 5.5 or section 5.5, you're going to be using factorial, but you're not going to be using it a lot because the calculator is going to be doing it for you. So you might have one like this on the test that you can actually do by your, in your head, or you might have one. Your calculator, I think, will go up to 69. Let's check that out. 69, math, probability, factorial, enter. I think 70 is it. 70, I don't think it'll do. Math, probability, factorial, enter. Yeah. So just make a note that 69 is the highest the calculator will go. 69 equals the highest calculator will go. Okay. Now, what can we do with factorial? Well, the questions you're going to see with factorial just by itself is the word arrangement, and flags question. The word arrangement and flag. So I give you a word. Let's say I give you the word smile. How many different arrangement of those letters can you make? Well, you count the letters. 1, 2, 3, 4, 5. And that's 5 factorial, which we said was what, 120? So with smile, there's 120 different arrangements. Did I say words or arrangements? I said arrangements because some of those arrangements doesn't make any sense. They're just a bunch of words. Okay? So let's check it out. Let's think of a 3-letter word. What's a 3-letter word? Trying to think of a meaningful 3-letter word, not and. What's a meaningful 3-letter word? I can't think of anything right now. Somebody help me out.
Dog.
Dog. There we go. I just thought of it. Same thing you did. Dog. I'm sorry. Dog. I don't say dog. I say dog. Dog. So that'd be 3 factorial, which is equal to 3 times 2 is 6. So DOG is 1. DGO is 2. GOD is 3. GDO is 4. ODG is 5. And OGD is 6. So there's your 6 different arrangements. Flags. Now I'm going to show you the flag question because I'm not going to write all that. I'll show you the flag. And these are also questions that'll be on a standardized test. So, but the flag question, I don't do the flag question on my test. To me, I'm like, who cares? It's kind of like that question you had in Johnny has 75 cents in his pocket. He has 3 dimes and 2 nickels. How many pennies and quarters does he have? Who the hell cares? I mean, that's one of those questions I'm like, who cares? All right, where is the flag question? Hold on, I'm trying to find the flag question. There it is. Write it down. let me go ahead and do, this is going to be on a standardized test. How many different vertical arrangements are there of 10 flags if 5 are white, 3 are blue, and 2 are red? This is flags/trees. You work on a golf course and you have 10 trees to organize on the golf course. 5 are oak trees, 3 are elm trees, and 2 are pecan trees. How many different arrangements do you have of those trees? And that's the trees/flags. And you're going to use this formula. It's n times, well, let me just get it for you. There it is. Okay? You got 10 flags, so you're going to start with 10 factorial. Well, what happened to the rest of the factorials? Well, they cancel. So it's 10 factorial over 5 factorial times 3 factorial times 2 factorial. That's how many different trees you got. Here's the arrangements, and here's the different trees, or I'm sorry, not trees, the different flags you have. And you're going to do that on your calculator. So let's go to the handy dandy calculator. And let's clear it. Now I'm going to try to do this as one. I've never done it as one, but I'm going to try to do it as one calculation. So on the top, parentheses, 10, math, probability, factorial, close parentheses, divided by, open parentheses, 5 factorial times 3 factorial times 2 factorial. Much harder with a mouse. Close parentheses and enter. So you've got 2,520 different arrangements of those trees or flags. And that's how you do that problem. Now remember, it's going to be flags or trees. Okay, now let's get to the 2 problems that I'm going to test you on. I've covered all the questions that could be on a test or a standardized test. Now I'm going to test you on, I'll show you the questions that I'm going to test you on. All right? And that is combinations and permutations. Combinations and permutations. Combination. What is a combination? Combination is an arrangement without order. Arrangement. Keyword. Without order. These are usually your lottery questions, your committee questions, supposed to be another T there, and some gambling questions. I don't think you have an E in there. Gambling, I think that's right. All right. Well, what's the permutation? And the formula for combination, I'm not going to write out the whole formula. I'm going to give you what's on the calculator. NCR. N is always your total or your biggest number. And R is always your smallest number in the question. And it's in your calculator as NCR. I'm going to give you the formula in just a second so you can write it down for your information, but that's the combination. Permutation. If a combination is without order, what do you think a permutation is? That's okay. You don't have to communicate. Arrangement. With order. Anything having to do with grades. Race. That could be a horse race or a foot race. Officers on a board. President or chairman, vice chairman, secretary, treasurer. Those are all examples of questions that you're going to see on the test, and that is going to be N, P, R, and of course N is your biggest number, R is your smallest number. And as I said before, they're on your calculator. Math, and it's number 2. And number 3. Okay? So let's go to the handy dandy South Carolina Education Lottery. South Carolina Education Lottery. And let's pull up the Powerball. It's up to 620 million. And there it is. I'm going to go down here. I'm going to click on it. And I'm going to pick how to play. And here is your test question right here. So I'm on Control C. Pull up the Word document. And give you a test question. There you go. Let me blow it up for you. There you go. And let me take that highlight off. And I can't, so you're just going to have to deal with it. Select 5 different numbers from 1 to 69 in the left play area, and then select a 1 ball, red ball, the Powerball, number 1 to 26. And they want to know, what is your probability of winning if you buy 1 ticket? Now let's talk about that, because some of your questions are not going to ask that. How do you win the lottery? What's the first step in winning the lottery? Somebody tell me. You don't have to be a rocket science. Just think. What do you got to buy?
A ticket.
A ticket. Nobody is going to win the lottery unless you buy a ticket. You've got to buy a ticket. So when the question asks you, what is the probability of winning? Probability of winning the lottery? They're going to assume that you bought at least what? One ticket. Now, some will not ask you for the probability of winning. Some will just ask, what is the probability? And they just want the denominator. Okay, now make sure you understand what I'm talking about here, because you're going to miss a question on the test if you don't understand it. If the question says winning, they're assuming that you bought at least one ticket, or they will say in the question, you bought one ticket, or you bought 15 tickets, or you bought 100,000 tickets. What is the probability of winning? Okay? If it just asked for the probability, then they're just wanting the denominator, which is just one number. Okay? They don't want 1 over that number. Okay? This right here is going to be your probability. One over the probability is your probability of winning. Just the probability is the denominator. So it's kind of important that you read the question. Okay? Because I don't want you to miss the question because you didn't read the question. So in this case, we've got, so I'm going to do this question right here. We've got 69, so we're assuming what is the probability of winning? 69 combination of how many? 5 times 26 combination 1. Now, a lot of you say, well, how did you know to do that, Hubert? Because you got to have this number and 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 this number. And what's in between all those numbers that I just said? What word did I use? You've got to have this number and 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 this number. I used the word what?
And.
And what is and? Multiplication. So you got to take your handy dandy calculator, and I'm going to do clear and clear, and I'm going to do 69. I'm going to put it in parentheses. 69 math probability NCR 5 times parentheses 26 math NCR 1 close parentheses. And that's equal to 201,338. That is your probability of winning. That right there. Okay. So let's look at the Powerball Lottery, and let's see what the odds of winning are. What is the odds of winning $620 million? Odds of winning. It's a miracle. 1 in 292,201,338. And you can impress your friends because you got that answer. And if you double it up, you get an extra 10 million. I'd be happy with just the 620. What would you do with $620 million? I would put it in the World Bank before I spent one penny. Because I live in West Anderson, West LA, somebody'd mug me if I carried it around in my truck. Somebody'd shoot me. All right, that is a combination. What is a permutation? Well, permutation would be like this. I'm going to give you one that's going to be on the test. You're betting you want to make a safe bet at a blank race. I'm going to say horse race. The reason I'm saying what kind of races are there? There's horse races, greyhound races, there's car races, there's bicycle races, there's all kind of races you can bet on. All right? I'm using a horse race because that's the most common. You want to make a safe bet at a horse race and make sure you win. So you want to place a bet, place a $1 bet on all trifectas. Anybody know what a trifecta is? Sounds like a disease, don't it? What is a trifecta? Anybody know? Just so y'all know I'm not making it up. Trifecta definition. A bet in which the person betting forecasts the first what? The first three finishers. In that what? If you're in a race and you pass the person in second place, what place are you? Good job. So that's a trick question. Some people get it wrong. All right, so here we go. I've got, oh yeah, there are 12 horses in the race. Therefore, we've got 12 permutation 3. So I'm going to take my handy dandy calculator and I'm going to go with 12 permutation 3. So that's going to be 12 math, probability, permutation 3. and I've got to place 1,320 bets. So I'm going to spend $1,320, but I'm guaranteed a what? I'm guaranteed a win. Because those horses, 3 of those 4 horses, 14 or 3 of those 12 horses have to come in what? All it takes, all you got to do is hit the little mute thing up here. Let me show y'all again. All y'all got to do is hit this little mute button right here. Right there on that, see? There, unmasked. See? That's all you got to do is hit that little. See, it's real easy. All right, I'm going to try it again. What am I guaranteeing myself?
That you win.
I only heard what?
That you win.
That you win. Now, what dictates how much money I win? Anybody want to answer that? Starts with an O. D. D. S.
Odds.
Thank you. I appreciate it. Thank you very much. I know that was really painful. Are you going to make it? I mean, you did communicate. I mean, are you going to be okay? I don't even know who it was. You turned it off so quick that I didn't even get to see the little light turn on. $1,320 guarantees that's an A, guarantees a win or a bet, winning a bet. Okay? Now, if you did $1,320, and let's say, okay, I'm going to give you all the reason for the odds, okay? Everybody, here we go. Here's the racetrack. And you got 12 horses right here. And there's 3 horses that are they're just pitiful. They just suck. Okay, there's 1. There's 2. And 3, I'm going to use a blue. And here's all the other horses up here. They're up here. I'm just going to draw a black circle up here. There's all the other horses. There's the other 9 horses right there. And they're going around the track. 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 And in the last turn, they all fall down. The 9 horses all fall down. And the last 3, the orange horse, I don't even have my orange marker anymore. The orange horse, the yellow horse, and the blue horse that started out sucking, they finished first, second, and third. Are you going to win a lot of money? Yes, because the odds are against those 3 horses winning because they were what? They suck. Okay, they're zebras or they're mules or donkeys or something. They're not thoroughbreds. Okay? So if something happens and these 9 horses fall down and these 3 horses come in first, second, and third, and you've got the trifecta bought up with $1,300, you're going to walk out like 50 to 1, 1,320 times 50, or let's say 500 to 1 times 500. you're going to walk out with $660,000. So that's why people do trifectas. But most of the time, who wins the horse races? Anybody watch horse races? I don't. But who wins them most of the time? The horses that are supposed to win them. Like Secretariat, like, what was it, Beach Biscuit or something Biscuit, Sea Biscuit. She won like 3 or 4, races at one time. These horses are bred and bred and bred till they're perfect. And y'all are not listening. Y'all don't care. Anyway. If it's not Marvel or a cartoon, it doesn't matter to y'all. All right. So anyway, that's how you do a trifecta. A trifecta is when you buy up all the winning, combinations and you hope for the long shot to be first, second, or third. Does anybody have any questions on 5.5? Because that's it. That's 5.5 right there. All right. Since nobody's going to ask questions and nobody's going to talk, we'll just go ahead and assign the test and go ahead and start the test up. So let's go to the main menu and go to 12038. Because I don't think y'all going to send any questions in, so that way we can go ahead and get the test out of the way. So assignment, let me pull up the homework, and since we're on 5.5 today, you should have the weekend. You should have everything finished on the weekend. So 5.1, 5.2, 5.3. I'm just going to do all of them, even though we're skipping some of them. And let me assign that one. And unassigned, unassigned, and assigned. And Monday or Tuesday will be what? Tuesday will be what? The 5th? That'll be the homework. And then let me look up the test. I usually don't do this, but since nobody's saying anything, I guess we'll just go ahead and do it. Let me go get the test, pull it up. We'll finish by 3/4 of the semester, as long as y'all don't ask questions. And let me pull up the Unit 3 test. Nope, that ain't gonna work. Hold on a second. I gotta go find the test. Let's go with, I thought I brought all my tests over. I guess I didn't. Import, copy, convert. 5th edition. There we go. Let's go with coordinated course. That's fine with me. Tests, and let me bring all those over. And go ahead and unassign these. Unassign and unassign. And go ahead and let's look at this one. Edit. And that's your test. And those looks like I need to, yeah, I'm gonna need to edit it. So I'll edit it after this afternoon. We'll go ahead and look at it though. I'm not gonna assign it because y'all will go in and take it and then I won't be able to edit it. So I'm just gonna save it. And we're not gonna assign it yet, but we'll go ahead and look at it. So Unit 2 test and preview. And just to give you a taste of what it looks like, there's your scatter plot. And I told y'all that scatter plot would be on there, and it tells you that is a negative correlation. It's not very strong, but it's a negative correlation. So the two have a negative association. Do the two variables have a linear relationship? They do have a linear relationship because it's kind of in a straight line. The data points have a linear because they do not. No, do, because they lie mainly in a straight line. Okay, I think it's B on that one. Next, let's check it. Yep. Next question you have. This is the one I told you that you would see. And remember that all probabilities equal what? 1. So which one is not a probability? Which one is not a probability? Anybody want to take a guess? Anybody? D is not. Can anybody tell me why D is not?
Has a negative.
Got a negative, exactly. All right, I think there's one more. I'm looking myself. I'm figuring them up in my head. 14, that'll be 2 14ths and 2 14ths. 5 and 5, that one's okay. Let's see. This right here would be 2 4ths, 2 4ths. I mean, 2 8ths, 2 8ths, 2 8ths. That's 6 8ths. This one is not. E is not. D and E is not. Let's look at this one. 6, 10, 11. I think D and E are the only ones that are not. So the rest of them are, and that's what they want. A, B, C, and F. A, B, C, and F. Next question. That's a bonus question. That's a bonus question. Bonus question. A lottery exists where balls numbered 1 through 15 are placed in the urn. To win, you must match 4 balls chosen in the correct order. How many possible outcomes? It's not asking to win. How many possible outcomes? So is this a permutation or a combination?
Permutation.
Permutation. So somebody do that in your calculator. Do 15 permutation, which is math. Permutation 4. 32, 760. 32, 760. Oh, I didn't check it. I'm sorry. There it goes. Next. 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 Okay, here is the problem I told you you would see, and they are, testing, there's your points, and they're also testing your correlation. R is equal to 0.94. And I'm not going to do this one. I'm going to let you do it. Put it in your calculator. Well, I'll put it in calculator or Excel spreadsheet. Open in Excel. And go ahead and draw it. Draw a graph. And insert chart plot. All right, that's what it looks like. 2, and then 2 get closer, and then 2 real close. So let's see which one that looks like. 2, 2, so it's D. All right, now it says there appears to be a linear negative correlation. And I guess they want, let's see, B, given that blah, 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 determine the least square regression line. All right, so we're going to go in and do the trend line. And I'm going to do the trend line right here. And that's the trend line, so I'm going to type that in. Let's see what it says as far as rounding. It says round to 3 decimal places. So negative 663, 6.831. Negative 0.633. And it didn't do the negative. And I don't forget the other one. Hold on. 6.832. 6.832. Well, check it. Okay, it won't let me check it. Let me go ahead and check the next one. Choose the correct, and I think it's going to be D. Okay, it says 80% correct, so I must got one of these digits off. Let me look at the digits again.
It was supposed to be negative 0.663.
I did do negative. I don't know what negative they want, but
It was supposed to be 663. I think you put
663. Thank you. I didn't take my medicine this morning. What is it when you transpose numbers? Dyslexia. My sister's got it bad, and I got it too, but I didn't take my medicine. All right, next, and I got a degree, a math degree. If anybody can get a math degree, I can. I mean, if I can get a math degree, anybody can. All right, and I've said that, and that's it. That's the type of questions I'm going to ask. I'm not going to pull any punches. I'm not going to try to trick you. I told you this would be on there. Remember I said, this is the way they write the complement. I do not write it like that. I write the complement like this. And that's, well, I've never seen it written like that. I write the complement like this. Probability of an event. The complement would be probability of an event with an X through it or a slash through it, or probability of an event with a line over it. I've never seen with a superscript C before. But this is a new book, and I'm going to do what it says, so that is also. So if the probability of an event is 0.29, what is the probability of the event not happening? What's the complement of 0.29 to probability? Take it away from 1. What is it?
0.71.
0.71. And you'll see one of those in your homework. I don't know why you haven't. It should be in 5.2, I think. The latter part of 5.2. So 0.71. Next. Fill in the blank. In probability, a blank is any process that can be repeated in which the results are uncertain. What is that? Well, sample space that's certain. We know it's either going to be a boy or a girl, or, I would say experiment maybe. You don't know what's going to happen in an experiment. And please don't put Army. Somebody missed that in here, I think. I can't remember. Somebody missed it. And let's see, what else? Okay. Will the following variables have positive correlation, negative correlation, or no correlation? Number of people in dinner party and amount of dinner bill. Wait a minute. The number of people in a dinner party and the amount for the dinner bill. Well, if you start off with 2, you're going to pay for 2, but if you start off with 5, you're going to pay for 5. So what is the bill going to do as the quantity goes up? The bill is going to go up. So what is that? Left to right, what's it doing? Left to right, positive slope, Hubert. That's right, class. Outside temperature and the number of people wearing coats. As the temperature goes up, what is your coats going to do? Go down. So as the temperature goes up, the coats are going to go down. So what is that?
Negative.
Negative correlation. And the only other one, outside temperature and the day of the week. There's no correlation there. Next. What is the probability of an event that is impossible? Suppose the probability is approximated to be 0. Does that mean that the event is impossible? What I tell you about words like impossible shouldn't be used. Okay? 0 is what they call for impossible. No, it is not impossible. Nothing is impossible. A survey of 100 randomly selected high school students determined that 61 played organized sports. What is the probability that randomly selected high school student plays organized sports? That'd be 0.61. So that means out of 1,000, how many? 610? Why am I not picking exactly? Why am I picking expected? Why did I not pick exactly? Because that's one of those words like perfect, impossible, exactly. Why do you not want to use the word exactly? Because it ties you down.
Is this just a sample?
Yes. So that'd be 610. A golf ball is selected at random from a golf bag. If the golf bag contains 5 brown balls, 9 yellow balls, 4 orange balls, find the probability of the following event. The golf ball is brown or yellow. What does or mean? Okay, I'm going to ask again. What does or mean? What does or mean?
Additive.
Thank you. I know that was painful. So how many, what is the denominator? Somebody tell me what the denominator is. $18, Hubert. And that's going to be a brown ball is what? Brown is 5. And a yellow ball is 9, right? So 9 plus 5 is 14. 14 over 18. It says round to 3 decimal places. They want a decimal. So I got 14 over 18. .778. And check it. Next. Determine if the following statement is true or false. Probability is a measure of the likelihood of random phenomenon or chance behavior. I would say yes. A certain lottery, and we done did this one, so I'm going to move on, see if we get another question. Another question. Suppose that events E and F and, remember and, are independent. Wait a minute, independent means what? That means without replacement. So this is multiplicative. And P of E is 0.3 and P of F is 0.6. What are you going to do? You're going to add them or are you going to multiply them? You're going to add them or multiply them? What does the word and means?
Multiply.
Thank you. And that's going to be what? 0.18. And that's it. I'm going to add some more questions to it. So you can't take it right now, but some of y'all got to finish your homework anyway. So I'll probably have it up by Friday. I mean, by Friday, tomorrow, yeah. All right, anybody got questions? No. So I'm going to go ahead. Does everybody know who we missing today?
Abby Bridwell was logged on, but her Chromebook messed up and wouldn't let her back in.
Okay. Why didn't she send me a message and I would have invited her back in?
Oh, she just texted us and told her, or told
Oh,
us.
she texted y'all but didn't tell the teacher. Okay, that's all I wanted to know. Y'all have got to communicate. This little game y'all playing, not communicating, it ain't working. Okay, I'm just telling you. You're going to get yourself in a mess not communicating. I don't bite. I don't know why y'all think I do. I'm calling up the roll because I don't know who else is not here, and I got 15 people on the roll, so I'm going to have to call the roll.